Question today is, how do I estimate and interpret using my, I'll say trend line, because line of best fit takes a lot longer to write, but it's the same thing. Line of best fit, trend line, just like slope and rate of change are the same, line of best fit and a trend line are the same thing. It's shorter, so I'm going to write that instead. Please go ahead. Great. In fact, a lot of times it's not gonna. Does not have to start at 0, 0. William? Should go through the middle of the points. So how can you make sure that happens? I'll say about equal, because it's not going to be perfect, but that'll make sure it goes to the middle. About equal points on each side. We talked about two more things, and these might be harder to remember. Okay, the points aren't going to make a perfectly straight line, so I'm going to say it has to have a linear relationship. It's got to look like, it's like a river. It's got to look like a river. If it doesn't look like a river, then we probably can't draw a line through it. So I'm going to say it has to have a linear relationship. And I'll put in parentheses, river. So if it looks like a lake, that means it has no correlation, and I wouldn't be drawing a line through it. This one, I forgot. Extend the line so you can predict in the future. So like keep it going to the right. Even if there's no points over there, keep the line extended. That way, when I ask you questions like I'm going to ask today, you can answer them. Okay, this scatter plot shows the relationship between the year and the average price of a baseball ticket. Just look at the graph right now. Think to yourself right now, what kind of correlation does that have? Think to yourself, what kind of correlation is that? Yesterday we talked about positive correlation, negative correlation, or no correlation. Guys, what is it? Strong, positive. Strong, positive. I agree, it's both, right? Strong means that the points are close to the line. If you look at this, they're really close. So yeah, I agree. Strong, positive correlation. Because it's going puff, puff, positive all the way up the mountain. Using the line of best fit. When I ask you any question about the average, using the line of best fit, in which year was the average baseball price $21? You have to use the line of best fit. Even if there's a point that's at $21, I am not asking about the point because that's one scenario. I'm asking in general, looking at the trend line, what was the case? We don't care about the points when I'm asking you interpreting questions. We care about the line of best fit. Because that is the trend. That's how it's trending, so that's what we're going to look at. So $21. So I'm going to go to my graph, and I'm going to find $21 on the graph. Isn't that right?
Right there. In half.
Here? Yeah. Halfway between 20 and 22. If I want to know the year, what do you think I should do? Go across. Keep it as straight as you can. And then, what Alice said, go down and see where you end up. What year was it $21 in? Okay, it's in 2004. Now, did I look at the point?
Negative.
I did not look at this point. I looked at the line, right? I looked where it hit the line. So it hit the line at 2004. So this is in year 2004. Gave you a lot of space to write that. I'm using the line of best fit because we're talking about an average. Using the line of best fit on the graph, what was the average baseball ticket price in 1997? Okay, 1997, when you guys weren't even born. 1997 is right here. Okay, this is important. I know that some of you are going to be like, well, look, there's a point right there. And so the average price was $12. Do I care about the points? No, we're asking about average. I don't want you to go to the points. I want you to go to the line. So follow it all the way up to the line. And then draw a line over to see where that hits. What did it actually cost? $13. I don't care about the points. I care about what the line shows me. $13. It says this scatter plot shows the relationship between the number of tables a waiter has served and the amount of money he has earned. And I use the word waitress and she because I didn't read the question. So we're talking about a waitress, but waiter, waitress, oh well. The equation for the line of best fit, it tells you is 1.67x plus 375. And it's already got the line of best fit drawn in for you. It's already got the points all there for you. So we're going to do some true or false questions. We're going to look at these statements and say whether it's true or false. A waitress has served 100 tables this month and should expect to have earned $540. So let's see if that's true. We're going to go to 100 tables, just like we did in the front. And we're going to go up to the line. Because do I care about this point that's at 100? No, I don't care about points. I care about the line. Because that's just one person's example. In general, the line shows us what's happening. Go all the way up to the line. Oh, you know what we probably should do? Because this helps me. Let's maybe label the halfway points so I understand what the heck those numbers are. Because Miss Weinstein, I'm telling you guys, she had to help me with this. Because I was like, is that right? 125, 375. It's going up by 125 each square. 625. Yeah, that's right. 875 and 1,125. We don't really need to do the last one. So now I got the halfway points. That's a little bit easier. Okay, so we drew a line up from 100 tables. And now we're going to draw a line over. Okay, so it's somewhere in between 500 and 625. There's $125 in between those. So I would say that's maybe like 550. I don't know. Because there's got to be 125 in between here. So that looks like it's about 550 or 540, I don't know, something like that. So let's see what it says. Waitress has served 100 tables this month, should expect to earn 540. Do you guys think that's about right? Yep, so we'll say true. Yep. Because we used the line. 275 tables this month and should expect to have earned $690. Go to 275 and draw a line up to see where we end up. Go to the line, not the points. So 275 tables all the way up and over. What do you guys, maybe that's like 800, is it like 850? Something like that, $850. So let's read the statement again. A waitress has served 275 tables this month and should expect to have earned $690. Is that right? Where did it hit the line? A little bit below 875. Is that 690? No. Okay, here's where the 690 came from, that point. Do we care about the points? No, we don't care about the points. care about the line. So we'll say false. It should be, what we say, about 850? Problem. Do you see 400 on this graph?
No.
I don't either. So we're going to have to use the equation. We're going to use the equation. So our equation, it says at the top is, so if it's not on the graph, use the equation, please. 1.67x plus 375. Let's write that down. This is why you might need your calculator today. Is it 375? Yeah. And tables is 400 tables. That's an x or y value. So let's put that where x is. 1.67 times, instead of putting x, I'm going to put 400 plus $375. Okay, did someone type this in your calculator? It looks like a few of us are still typing it in. I'll give you just a few more seconds. William's got 1,043. That's a lot of money. Okay, so a waitress should expect to make about 1,050. Is that pretty close? Mm-hmm. True. I would say that's pretty dang close. Right, we're rounding. We're approximating. Next three statements are all really similar. And so only one of them is going to be correct. So we're going to read all three. Every time a waitress serves one more table, the waitress should be expected to earn $125 more. I would look at the equation. P.S. Every time a waitress serves one more table, the waitress should be expected to earn $3 more. Or every time a waitress serves one more table, the waitress should be expected to earn about $1.70 more. We're asking about the amount of money earned per one table. I'm asking about the change in y over the change in x, which is money over tables. Change in y over change in x. What's another name for change in y over change in x?
Rate of change.
The rate of change, or rise of a run, or
Y1 plus.
what's the, you're saying all good things. What's the really short name?
Rise over run.
No. Slope.
Slope.
Slope. Okay. I'm asking about the slope. What is the slope, guys? 1.67 is the slope. It's a number in front of x. So 1.67 is the slope. Okay, let's look at that. 1.67 over 1. That's saying you get $1.67 over 1 table. Change in y over change in x. So which statement is right? D, E, or F?
Yeah.
F, because it says $1.70 more, which is a little bit rounded, but that's the closest. So the other ones, 3 and 125, are incorrect. So if I ask you a question like this, you need to look at the slope because it's how it's changing over and over. So these two are false.